Process capability. We are Advanced Innovation Group, your partner in business excellence. Leading experts in Lean, Six Sigma, Green Belt, Black Belt, Master Black Belt. Hands-on training with real-world case studies and projects. Industry-recognized certifications for career growth. Expert trainers with proven business impact. Trusted by companies to optimize processes and improve efficiency. Why process capability matters? Think about it. How does your company ensure products or services consistently meet customer expectations? How do you know if your process is capable of delivering quality every time? That's where process capability steps in. Whether you're in manufacturing, service delivery, or customer support, process capability tells you how well your process performs relative to set specifications. It helps identify if the variation in your process is acceptable or if improvements are needed. Today, we'll explore how understanding and measuring process capability allows us to deliver consistent quality, reduce defects, and rework, improve efficiency and customer satisfaction. Let's dive into the tools and concepts that make this possible. Process capability measurements. Evaluate consistency of process output. Recap normal distribution, bell-shaped curve, symmetrical data spread. Process capability ratio. Compare spread to specification range. Understanding limits, specification and control. Distinguish between natural and allowable limits. Z-score, distance from mean in sigmas. DPMO, defects per million opportunities calculated. CPCPK, measure potential and actual capability. What is process capability? Process capability is the degree to which a system or service meets customer expectations or ability of a process to produce defect-free products. While you intend to study process capability, it is recommended that you understand the normal distribution well. Recap normal distribution. Normal distribution and mean. Explained. A normal distribution is a bell-shaped curve that represents the distribution of a dataset where most values cluster around the central peak, and probabilities for values taper off equally in both directions. The mean is the central vertical line in the image. It represents the average value of the dataset, is also the peak of the normal curve. The point of highest probability lies exactly in the center of the distribution. In a perfect normal distribution, the mean equals the median equals the mode. Recap, normal distribution. If you were to superimpose customer specifications, USL, LSL, you can get meaningful stats about process performance. Specification limits are decided, mostly by customer. They may give you one-sided or two-sided specification, sometimes is self-imposed. As part of your offering, you give yourself some spec for performance. Law of the land can also specify acceptance tolerance area outside the specification limits are your failure area. Control limits are decided by the data itself. You collect data and your upper control limit and lower control limits are calculated from the data itself. Control limits are not provided by customer. They represent process performance. Z-score. Process capability ratio, Z-score. How many standard deviations can I fit is Z-score. In real life, we may have two-sided or one-sided specification. Only two-sided specification is mostly applicable in dimensional data, e.g. measurements. Manufacturing example. A cloth manufacturer has been asked by customer for cloth, which should not be less than 140 centimeters and should not be greater than 160 centimeters. While creating door frame, manufacturer is required to make door frames not greater than 5.01 feet and not less than 5.0 feet. Service example. Customer has mandated that the call handling time should not be more than 3 minutes and should not be less than 30 seconds. Cited specification is present almost everywhere. Manufacturing example. A biscuit manufacturer has been given target that breakage percent should not exceed 1%. ppm target for a firm set at maximum of 1,000. Leakage percent acceptable to customer in a compressor making process is 1%. Service example. Customer has mandated that the call handling time should not be more than 3 minutes. At AIG, we want that BB course completion TAT should not exceed 150 hours. Claim closure TAT in a motor insurance process was mandated to not exceed 13 days. Calculating Z for one-sided specification. Let us understand through examples, when only USL is available. Assume you work with Claims Management Unit and you have SLA of handling time at 3 minutes. Anytime you take greater than 3 minutes, it shall be considered as defect. Should you look at calculating the Z-score for this process, follow the steps below. Decide if specification is USL or LSL. In this case, it is USL. Going beyond 3.0 min shall be termed as defect. Calculate the mean and standard deviation of the data of delivery TAT. Let us assume that the mean equals 2 min and std dev is 1 min. Use the formulae Z USL equals USL minus mean divided by standard deviation Z USL equals 3 minus 2 divided by 1 equals 1. In the above example, as we have only one-sided specification, we shall consider the Z USL as the Z-score of the process. Calculating Z for one-sided specification, con-TD, when only LSL is available. As part of the SLA signed with the customer, the target for accuracy score as given by them is 95%. Upon analysis of the audit scores received from the quality team, we find that the mean is 98% with standard deviation at 1.5. Use the formulae Z LSL equals mean minus LSL divided by standard deviation Z LSL equals 98 minus 95 divided by 1.5 equals 2. In this example, as there is just one-sided specification, i.e., the LSL, Z, LSL shall be considered as the Z-score of the process. Calculating Z for two-sided specification. In case you have two-side specification from customer, X, if we are under contractual obligation to deliver cloth between 140 centimeters and 120 centimeters, customer has mandated that cloth greater than 140 shall not be acceptable, and less than 120 is not acceptable. As in the one-sided examples, first steps shall be to calculate mean and standard deviation of the produced cloth. Let us assume that the calculated mean is 130 with standard deviation of 10. Define the USL and LSL of the process. In this case, USL is 140 centimeters and LSL is 120 centimeters. Using the same formulae of Z, USL, and Z, LSL, calculate the value. Z USL, Wunsch USL, mean, STD, dev, Wunsch 140 minus 130, divided by 10 equals 1Z. LSL Tiki, mean, LSL, STD, dev, Shigid 1. Calculating Z for two-sided specification, CONTD. The next step shall be to look up the Z table to get the DPO value for the Z scores received for both sides. DPO, USL, equals 1.59 times 10 to the negative 1 power. Remember this mathematically equal to 1.59 divided by 10. DPO, LSL, equals 1.59 times 10 to the negative 1 power. DPO overall equals DPO USL plus DPO LSL, i.e. To calculate the final DPO, add the DPO score of both sides. You would get value of 3.18 per 10 or 3.18 e to the power of negative 1.